Okay, appreciation, depreciation. Let's go through a few problems here and go through the lesson. So here's a warm-up. Try the warm-up on your own, but and as you do, pause this video and then we'll come back to it. So hopefully you got a chance to try it. So here's the question. Dylan purchased his first car 4 years ago. He paid $10,000 for it on a used car website. The exact make and model for this car can be purchased for around $6,000 now. How much of his car's value as a percentage was lost over the last 4 years? So to go from 10,000 to 6,000, I'll subtract those two values, and then you get that number 4,000. Okay, but to get the percentage lost, I have to take that amount, 4,000, and divide it by the original cost of the car. So 4,000 divided by 10,000, which gives you a fraction. And then because we want it as a percentage, I'm going to just multiply that by 100% to get to arrive at my answer. So the answer here, again, if you're doing this without a calculator, you just, well, you can cross out zeros. 4 out of 10 fraction to a decimal is just 0.4. Okay, so 0.4 times 100, which is equal to 40%. So Dylan lost the 40% of the value of his car. Okay, as a general formula, how do we do this in general? We just take the initial value minus today's value, or the final amount, divided by the initial amount times 100. So as you can see here, the initial amount is 10,000, and the final amount is 6,000, and then you divide that by the initial amount 10,000, and then multiply by 100%. That's how we calculate the change, or the percentage change of the value lost over the 4 years. Here's another warm-up question. Dylan's parents moved 4 years ago. They paid $551,000 for the house in the photo. If you look at Desmos, you'd see a picture. A similar home on the same street sold last week for $788,000. How much has the value increased as a percentage over the last 4 years? Okay, so here, because this is the bigger number, what I'm going to do is take the 788,000, take away the what they paid, initially 551,000, and then divide that by the initial amount, 551,000, times 100%, because we're looking for the percentage increase, right? So 788 minus 551, if you take a calculator and you subtracted those two values, so that's an increase of $237,000. So to go from 551 to 780, that's an increase of $237,000. I divide that by the initial amount of money they paid for the house, 551,000, and I get it, and I multiply that by 100% because I want that answer as a percentage, and then we get an answer of 0.43 times 100%, which is 0.43. That fraction turns into 0.43 times 100%, which is a total of 43%. So there's a 43% increase in the value of the house over the last 4 years. Okay, so for percentage increase, you take the final number minus the initial number, and then you divide by the initial number times 100%. Okay, so that was our quick warm-up. Here's a look at today's lesson's main definitions. Appreciation. So we know the warm-up examples show you a couple of things. One warm-up question shows you a decrease in the value of an object, and the other one goes an increase in the value of an object. So that's what we call appreciation and depreciation. Appreciation is the increase in value over time, and depreciation is a decrease in value over time. Okay, so that's important to note. So we have things that in life that appreciate in value, and then some things in life that depreciate in value. These are financial terms, right? So we have other meanings, appreciating someone, right? And that's a different appreciation, right? But appreciation in terms of assets and amounts, we're talking about the increase in value of something over time. So some examples. So what are some examples of items that depreciate? So think of some examples and write them down. Okay. So pause the video and think of a few examples and write them down. Okay, so hopefully you had a chance to write some down. I'll give you some if you couldn't think of any, or if you were missing some from your list, try looking at these ones here. So houses generally appreciate in value over time. Okay. So houses or property. Okay, we can say property. Land, right? Land is something that could appreciate over time. Commodities like maybe gold, precious metals like gold can increase in value over time. Okay. So yeah, think of maybe some collectibles, whether they be dolls or cards, like collectible card games or sports cards. Some things like that could increase in value over time. Okay, so think of what increases in value over time if you hold it for a few years or a decade or more. What about items that depreciate? So there's certainly things in life that depreciate in value over time, right? So, cars are an example, right? No one wants to pay the sticker price for a used car, right? There's some, you drive the car, it wears and tears, it's going to lose value over time. No one's going to pay you full amount for it after a few years. Okay, equipment, perhaps computers, right? Like, newer computers come out every year, faster computers come out every year. No one's going to buy an older computer for the same price that you paid for it, right? So the value of computers depreciate over time. Okay. So anything, usually anything that has wear and tear, small items, right? That can depreciate over time. Maybe furniture, right? Like things that you could sell used, but no one will pay the full price for when it was brand new. So think of that. So those are just some examples. And there are many examples. Think of more and more and more, and you can complete this list. Okay. So that's the main goal of this lesson. Can we identify things that appreciate and depreciate based on what they are? Graphs, situations. So like here's an example where we have a graph of the price of something with respect to time. So price on the y-axis, time on the x-axis. So this graph displays the average Canadian real estate prices. Real estate meaning like homes, condominiums, houses, land, okay? And the prices that go from the year 2005 to 2021, just last year, okay? So overall, are the values appreciating or depreciating? Well, if we start from the beginning of the graph, we see an amount like, let's say 250,000, okay, and it goes all the way up to 2021. It's close to 750, maybe just under 750, 730. Okay, so we see a trend that is increasing. The prices are increasing over time. As we read the graph from left to right, it's increasing over time. So if it's increasing, and we said appreciation, or definition of appreciation are things that increase in value over time. So here we go. We're going to say this is appreciating. So the values are appreciating because the graph increases over time. Okay, can we estimate the average rate of appreciation? Well, if we're going from 250 to, let's say, 730, okay, so what's the difference? 730 minus 250 equals what? Well, 730 minus 250 is equal to 480,000. So from 2005 to 2021, we've gone from 250 to 730. That's an increase of $480,000. Over how many years is that? Well, if you're going from 2021, 2005 to 2021, if I subtract those two values to get the change between the two values, that will be a difference of, how many years is that? That's a difference of 16 years. Okay, 16 years. So it's went up to $480,000 over 16 years. What's the average rate then? So if I divide that $480,000 divided by the 16 years that occurred, right, then I can get an answer for how much, on average, the house prices increase every year. And they increase every year. If I divide those two numbers, $30,000. Every year it increases by $30,000 on average, right? So if you look at the graph, some years, it looks steady, then there's a drop, then up again, then drop, and then up again. Here's a more steeper increase, and then steadies out, and then it increases more and more again. But we're saying on average, like a straight line on average, how much does it increase? It increases by about $30,000 a year. Okay. Name two periods that show a higher than average rate of appreciation. Well, the higher rates mean a steeper. Think of a steep slope of a line, right? A higher rate of change means a steeper slope. So I got a steeper slope here, and I got sort of a steeper slope here. So between 2015 and 2017, and then maybe here from 2019 to 2021. Okay, so we can say from 2015 to 2017 and 2019 to 2021. You got some very steep lines. So those steepness means the rate of change is more higher than the other time periods. Okay. Let's have a look at another graph. Here's a graph that shows the value of a shares of a corporation, like stocks. Like shares means stocks. Have you ever heard of stocks? Stocks are what give you ownership of a publicly traded company. Okay, so maybe one day you might be interested in investing in stocks, and you'll be looking at the values of shares over time. So suppose someone bought shares in 2010 of this corporation, this company, and sold them in 2014. This person experienced an appreciation or depreciation. So we look at the graph. We go 2010 is right here. This is where it starts. And then it goes to 2014. So here is where it ends when we're studying this path here. This looks like, if I highlight this part of the graph, it's an increase, right? That's an appreciation of the value, because the y-axis is the average share price, goes from $22 or so all the way to $40. Really nice return on the investment there. So that is a appreciation, right, from 2010 to 2014. Okay, the graph is increasing from in that time period. That's how we know. Okay, so suppose someone bought shares in 2015 now and sold them in 2020. They experience appreciation too. Well, if you bought them in 2015, here's 2015. Okay, the price would be about $27 because it dipped after 2014. And then they sold them. When did they sell them again? 2020. So if I look at 2020, up here we go. Here's 2020. If I read the value, from that point to that point, looks like it has dropped in value. That would be a depreciation. Okay, so a depreciation because there is a drop in the share price at 2015 of how much? Let's see. 2015 they paid about $27 down to $17. Okay, so of $27 to 2020 of a price of $17, right? So it was 17. Let me just make sure. Yeah, about 17 and a half maybe. Okay, $17. So this is a depreciation. Okay, so this is what we got to know, how to read some of these graphs to understand what does depreciation mean, what does depreciation mean, and how we can determine that. Okay, so that's the end of this video, and you can work on some of the practice problems for this section.